Hello again, students. Hello. Okay, now we're going to do not just a conceptual problem, we're actually going to do something numeric. And in this problem, we have three charges, Q1, Q2, and Q3. You can see their magnitudes over there in the upper left-hand corner, and not just magnitudes, but their signs. And then you can see their arrangement basically along the x-axis that I drew there. So Q1 and Q2 are separated by a meter, Q2 and Q3 are separated by 2 meters. And what I want to find is the force on that middle charge, again, the force on Q2. So this is a time where I'd like you to pause the video and work out this problem. Did you pause it? I hope you did. If you started to work on it and you got stuck, let's first talk about procedure here. The first thing I'm going to do, just like I did in that conceptual video, is I'm going to draw arrows representing the direction of the force. Notice these are all positive charges, so that means that they're going to be repelling each other. So if Q1 and Q2 are positive, the force on Q2 due to Q1 is to the right, repelling. And then, again, Q2 and Q3 are both positive, so that's going to repel. Q2 is going to be repelled by Q3 to the left. And this is important when we figure out what these numbers are, so we add them up correctly. Now that I've done this, I want to find F12, find F32 using Coulomb's law, which we introduced in class on Friday. And then I want to add them up correctly to get the total F2. So if you paused it before and you couldn't quite get to an answer, now is another good time to pause it and try that. Okay, so let's go through the solution. Let's start by finding F12. It's the force on 1 due to 2, and if you're thinking about Newton's third law, yep, that's also the force on 2 due to 1. We don't care about that, right? We're just trying to find the forces experienced by 2. K is that constant we talked about that is 9 times 10 to the 9th. Our charges are in nanocoulombs, remember, which we know is times 10 to the negative 9th. So I have 5 times 10 to the negative 9th. And 3 times 10 to the negative 9th. And then I'm dividing by the distance between those two charges, which is 1 meter. And I'm getting that F12 is equal to 1.35 times 10 to the negative 7th newtons. A reminder that this is just a magnitude. This is not an amount. In other words, this is not giving us the direction. We figured out the direction earlier by using the logic of these are both positive, it's going to repel, so the force is to the right. We're not getting the direction of that force out of this formula. Now, I'd like you to hang on to this number if you're working along with me, because I don't have room for it on here on the tiny whiteboard on my fridge, so I have to erase. And get a quick view of my pantry and my water dispenser and my fridge. It's all very exciting here. Okay. Now let's find F32. Same thing. K. Q3, which is 6 times 10 to the negative 9th. Q2. Then divide by that distance between them, which is 2 meters. And I get that F32 is equal to 4.05 times 10 to the negative 8th newtons. Again, that is just the amount, just the magnitude. It is pointing to the left. So now my next step is to combine them. And because they're both vectors, direction matters, so I can't just add up 1.35 times 10 to the negative 7th and 4.05 times 10 to the negative 8th. I have to take into account their direction. And so their direction here is that one is positive and one is negative, but they are all along the x-axis. They don't have x and y components. So I'm going to make F12 positive, I'm going to make F32 negative. F2 is going to be F12 minus F32, which is going to be equal to 9.45 times 10 to the -8th newtons. And I didn't specify how I wanted you to report the direction, so it's fine to say to the right. If you want to say I hat, positive x direction, something like that. Yeah. Okay. So if you have any questions about this, I can't answer them because I'm just recording a video right now, but I hope you email me or you ask me during my office hours. The last video is going to be using these same 3 charges, except we're going to arrange them so it's a 2-dimensional problem. A little bit more interesting. A lot more trig.